Guten Tag, meine Damen und Herren, and willkommen in Chemie. And we are in part 3 of stoichiometry, our discussion on stoichiometry. So let us take a quick review, right? We're talking about stoichiometry. Oops, can't read green on this. Here we go. We were talking about stoichiometry, right? And we said, hey, what are we doing with stoichiometry? We are essentially doing analyzing the masses of reactants and products in a chem reaction, right? And we're showing the relationships between them. We're able to predict things. And we have some problems that we can do. We can do different kinds of calculations. And they all really run off of one idea, right? That if I have a reaction, that the moles of each of these can be related to one another through something called a mole fraction, a mole ratio, right? That a mole ratio would be equal to the moles of one of my component over the moles of another of my component. And this mole ratio is determined by the coefficients in my balanced equation. So that in this reaction, I would have 1 mole of oxygen for every 2 moles of water. Now, once we set this up, we can start off with a given of any kind and go either from water to oxygen or oxygen to oxygen to hydrogen or oxygen to water, right? We can go everywhere within this equation just using a variety of mole ratios, right? And we said we could start with moles, and I can go to moles. I can start with grams, and I can go to no. I can't go from grams to grams, can I? I have to go from what? Grams to moles, and then moles to moles, then moles to grams, because these coefficients are not gram ratios. These guys do not represent gram ratios. These guys only represent mole ratios or molecule ratios. Although we rarely use molecule ratios, we're almost always using mole ratios, right? So that's our overview, you might say, of stoichiometry. So here we go. I have, 3 nitrogen dioxides plus water yields 2 nitric acids and nitrogen monoxide. Okay, we've seen that before. If I were, oh, we've done this. Sorry, we're on the wrong, we have to go somewhere else. Here, yoink. Here we go. Consider 28 hamburger patties, 26 slices of bun, and 25 slices of cheese. How many Big Macs can you make? Okay, we have to go back and remember our recipe for a Big Mac. What do we have? 2 hamburger patties, 1 slice of cheese, 3 slices of bread. Okay. There we go. So what did I say? 2 hamburger patties plus 1 slice of cheese plus 3 slices of bread, and that makes 1 Big Mac, right? And what do I do? I start off with 28 of these. I have 63, nope, I have 25 cheeses, and I have 63 slices of bread. How many Big Macs can I make? I'm not sure. Let's see. This is confusing for me a little bit. Let's do these one at a time. If I have 28 hamburger patties, and what's my ratio of hamburger patties to Big Macs? Well, I have 1 Big Mac per 2 hamburger patties. Okay, good. So my hamburger patties cancel, and what do I get? Okay, 14 Big Macs. So if I had 28 hamburger patties and lots of other stuff, the most I could make is 14 Big Macs. Okay, what about with 25 pieces of cheese? Well, what's my ratio? 1 Big Mac per 1 piece of cheese, and I would make what? 25 Big Macs. So if I had 25 pieces of cheese and lots of hamburger patties and lots of buns, the most I could make is 25 Big Macs. Now, what about if I have 63 slices of bread? I can make what? One Big Mac for every 3 slices of bread. And so that would mean I would have 21 Big Macs that I could make. So if I have 63 slices of bread and lots of cheese and lots of hamburgers, I could, subjunctive here, make 21 Big Macs. But given all 3 of these, given 28 hamburger patties and 25 slices of cheese and 63, how many Big Macs can I really make? Can I really make 21 Big Macs if I only have 28 hamburger patties? No, I can't really make that. Can I make 25 Big Macs if I only have 28 hamburger patties? No. The most I could make if I have 28 hamburger patties is 14 Big Macs. Got it? So which ingredient limits the number of Big Macs? Hey, the hamburger patties do. Okay, great. Let's move on. Consider this reaction. If you were to react 25 grams of nitrogen with 20 grams of hydrogen, which reactant would be the limiting reagent? Okay, looks like we need some notes here, right? So let's go up to our notes. I think here are our notes. Stoichiometry. Oh, we have some stoichiometry here. I'll tell you what, let's go to our other notes. The ones I started here. Stoichiometry, this beautiful calculations. We're going to come off of calculations here, right? And we want to talk about limiting reagent or reactant calculations. Reactant or reagent. Okay, so first we want to define that. What is the limiting reagent? It is the reactant which limits the amount of product which can be produced. Now, a corollary to that would be, hey, what does that mean? What it really means is this is the reactant which is completely consumed in the reaction. Because when it is completely consumed, what happens? Once it is completely consumed, the reaction ends. Great. So I would accept either one of those as a reasonable definition. Now let's talk about the process. Okay, here's what we're going to do. Here's the process. Number 1, take a reactant. It doesn't matter which one. Take one of them. Convert to moles. Calculate moles of a product using mole ratio and moles of this reactant, just to clarify that. Okay. And how are we going to do that? We're going to use mole ratio, sorry. 2, take second reactant, convert to moles. If it's not already converted to moles, convert to moles. Calculate moles of product, same product that you calculated up here, this same product. Calculate moles of same product using mole ratio and moles of second reactant. 3, compare moles of product calculated in step 1 versus in step 2. Whichever reactant, whichever reactant produced the lesser amount, which I should put this in the subjunctive, which would produce the lesser amount, is the limiting reagent or reactant. Got it? It's not that hard. Just follow the step, right? Here we go. Let's do it. So I've got two reactants, nitrogen and hydrogen, right? What am I going to do? Well, I have 25 grams of nitrogen. I'm going to start with nitrogen. That's the first one I'm going to do. I'm going to convert to moles, so I need to get moles of nitrogen. Moles of nitrogen are going to equal what? 25.0 grams times 1 mole per, well, need to go up here. What is my molar mass of nitrogen? 14.01. And how many nitrogens do I have? 2. So 2 times 14.01 grams per mole. And what do I get? So here we go. 25 divided by 28.02. And I get 0.8922 moles of N2. Got it? So now, let's look at moles of ammonia. How many moles of ammonia could be produced by this nitrogen? Well, it's going to be 0.8922 moles of nitrogen times what? Well, my mole ratio, 2 moles of ammonia per 1 mole of nitrogen, right? And so what do I have to do? Looks like I have to double this, right? Yoink, yoink, times 2, and I get 1.784. That's not significant, right? The 4 is not. Moles of N. Okay, that means what? If, subjunctive, if 25 grams of nitrogen were to react, then I could produce 1.784 moles of ammonia. Now we do the same thing with what? With my hydrogen. So we're going to take hydrogen and its grams. So we're going to get moles of hydrogen. And moles of hydrogen are going to be 20.0 grams of hydrogen, H2, times what? 1 mole per 2 times 1.008. Yeah, I remember I made my mistake the other day, didn't I? There we go. And what do I get? 20 grams divided by 2 divided by 1.008. And it looks like I get 9.920 moles of H2. Now, how many moles of a nitrogen, not nitrogen, ammonia, could I get out of this? Okay, 9.920 moles of H2 times, what's my mole ratio? 2 moles of ammonia per 3 moles of H2. Yeah? Good. Divided by 3 times 2, and I get 6.613 moles of ammonia. So 6.613 moles of ammonia could be produced if we were to react 20 grams of hydrogen. Okay, now what do? I compare these amounts. Let's compare these two amounts. Which one is smaller? Well, this one is smaller. If this is smaller, that means what? That means my 25 grams of nitrogen run out, are completely consumed when 1.784 moles of ammonia are produced. Then that means it's impossible for me to get 6.613 because I wouldn't have any nitrogen left. So having said all that, what is my limiting reagent? The limiting reagent is nitrogen, right? I found the product amount that was the lesser amount and then go back to the reactant which would produce that lesser amount. Well then, what's the excess reagent? Well, the excess reagent is the reactant which is not limiting. So that would be H2. Got it? And how many grams of ammonia could be produced from this reaction? Well, that is the amount. Let's maybe go back to our notes here for a second, and let's talk about amount of product which could be produced. Okay, what's the amount of product which could be produced? And that is the amount calculated using the limiting reagent. So the amount that comes from our calculation with the limiting reagent is the amount that could be produced. So let's go to our answer here. How much could be produced by, how much was produced by my limiting agent? 1.784. So how much could be produced? The answer is right there. 1.78, 3 sig figs now, moles of, not moles, that's not moles. I need to do what? Oh yeah, I guess I do. That's moles of ammonia. So that I shouldn't round yet. There we go. 1.784 moles of ammonia could be produced, but we don't want moles of ammonia. We want grams of ammonia. So what do I have to do? I have to multiply this by what? 14.01 plus 3 times 1.008 grams per 1 mole, right? Where did I get that? Well, that's my nitrogen molar mass. Where did I get the 1.008? That's my hydrogen molar mass. Okay, here we go. 3 times 1.008 plus 14.01, cool, 17.034 times 1.784. What do I get? Woohoo! 30.4 grams of ammonia could be produced if I were to react 25 grams of nitrogen with 20 grams of hydrogen. Okay? All right. Now notice something here. There is something a little bit counterintuitive about this. Which reactant actually had fewer grams? Well, I have 25 grams of nitrogen and 20 grams of hydrogen. Okay, so I have less hydrogen. So initially you'd think, oh, well then hydrogen's going to run out and it's the limiting reagent. And that answer is wrong, right? And why is that? Well, because it's not about grams, it's about moles, and it's not just about moles, but it's also about all of these mole ratios. So it's very difficult to just look at the grams of my reactants and guess the right answer. I have a very difficult time at that. I always have to follow these steps. I have to take my grams, convert to moles, take my moles, convert from moles of reactant to moles of product, do the same thing with my other reactant. Good. Here you go. You guys give this one a shot and bring me back when you're ready. Well, what's the first thing I want to do? I want to get moles of my nitrogen dioxide, which is equal to 1224 grams times 1 mole per grams of what? NO2. 1 mole of NO2 per what? 14.01 plus 2 times 16.00 grams of NO2. Great. And so what do I get from this? I have 16 times 2, which is 32, plus 14.01. Good. I'm going to take the inverse of that, so I have a very small number times 1, 2, 2, 4, and I end up getting 26.602 what? This cancels, moles of NO2. Now what do I want to do? I want to go to a product. Which product? I don't care. Sometimes I kind of look ahead and I say, ooh, you know what they're going to ask later? They're going to ask about nitric acid. Well, then why don't I go to nitric acid? Yes, that would be the smart way to do it. I'm going to figure out moles of nitric acid. So how many moles of nitric acid can I get out of this amount? Well, 26.602. That's not significant, that 2 isn't, right? Moles of NO2 times what? Well, I have 2 moles of nitric acid per every 3 moles of nitrogen dioxide. Good, so times 2 divided by 3, and I get 17.735 moles of nitric acid could be produced if I were to react 1,204 grams of nitrogen dioxide. Now, what would happen if I were to react 1,224 24 grams of water? Well, moles of water, 1 mole of water per, let's see, 2 times 1.008 plus 16.00 grams of water. Okay, so what is that? So 16 plus 2 times 1.008 equals, okay, 18.016. So I'm going to divide that into 1224, and it looks like 67.939 moles of H2O, right? Moles of H2O, have to look, grams, yeah, moles of H2O. And then what? I want moles of HNO3, and that's going to be what? My 67.939 moles of H2O times my mole ratio, right? 2 moles of nitric acid per 1 mole of H2O. So I multiply that times 2, and I get 135.8 moles of nitric acid. Now what do I want to do? Well, I want to compare these amounts. I want to compare this to this. Well, which is the smaller amount? Well, this is the smaller amount. If that is the lesser amount, that means what? That means this is my limiting reagent. So my limiting reagent would be nitrogen dioxide. Good. How much nitric acid would be produced? Well, the amount that would be produced of a product is the amount which would come from, that is calculated from the limiting reagent. So that would be 17.74 moles of nitric acid. Now you notice it doesn't say here grams or moles, so I could answer that in any way I want. And I'm going to just say moles because that's what I have. If you happen to do that in grams, just in case you were a striver and put that into grams, what would that be? Well, I need to multiply that by what? 1.008 plus 14.01 plus 48.00. So times the, 1.008 plus 14.01 plus 48 equals times 17.7, let's get the unrounded amount, 735 equals, okay, 4 sig figs, I get 1118 grams of nitric acid could be produced if you were to react all of the 1,224 grams of nitrogen dioxide. Yeehaw! Well, I think that's enough for today. We will do probably 2 more lectures in stoichiometry, and then we are done, and you will be masters of stoichiometry. See ya.